The 2008 National Electrical Code introduced several important changes, particularly regarding wet locations, ground fault circuit interrupter protection, and metal stud bonding. One significant change concerns receptacles installed in wet locations. The code now requires that all receptacles in wet locations must be listed as suitable for wet locations. This requirement applies regardless of whether an in-use cover is installed. The listing ensures that the receptacle itself is designed and constructed to withstand the harsh conditions present in wet environments. This means that the receptacle materials, construction, and internal components are resistant to moisture, corrosion, and other factors that can compromise the safety and performance of electrical equipment in wet areas. It is important to note that the requirement for listed wet location receptacles does not necessarily eliminate the need for in-use covers. Depending on the specific application and local code interpretations, an in-use cover might still be required in conjunction with a listed receptacle to provide an additional layer of protection against water intrusion and physical damage. Another important change in the 2008 code involves the zone described in section 410.4.4d. This section establishes a zone around bathtubs and shower stalls where specific electrical requirements apply. The code now clarifies that the zone described in 410.4.4d applies generally and is not limited to the specific requirements outlined in that section. This means that the area within the zone is considered a wet or damp location for all electrical installations. Consequently, any electrical equipment or wiring installed within this zone must be suitable for wet or damp locations. Receptacles located within 3 feet of a shower or bathtub in a bathroom may require a weatherproof cover. This requirement aims to enhance electrical safety in bathrooms by minimizing the risk of shock hazards associated with moisture exposure. The code also addresses ground fault circuit interrupter protection. Section 410.73.7g of the code may be expanded to require ground fault circuit interrupter protection for all branch circuits, not just multi-wire branch circuits. This expansion would broaden the scope of ground fault circuit interrupter protection to encompass a wider range of electrical circuits, enhancing safety by reducing the risk of electrical shock from ground faults. Ground fault circuit interrupters are designed to detect even small imbalances in current flowing through a circuit. When a ground fault is detected, the ground fault circuit interrupter quickly interrupts the circuit, preventing electrical shock. This expanded ground fault circuit interrupter requirement would provide an additional layer of protection against electrical hazards in residential, commercial, and industrial settings. Finally, the 2008 code addresses the bonding of metal studding. A proposal was submitted to require the bonding of metal studding regardless of whether it is exposed to contact. The code-making panel supported this change, indicating a growing recognition of the importance of bonding metal studding to ensure electrical safety. Bonding metal studding helps to create an equipotential plane, reducing the risk of electrical shock by providing a low impedance path for fault currents to flow back to the source. When metal studding is properly bonded, it minimizes the potential difference between the studding and other grounded metal objects, such as conduit equipment enclosures and grounding electrodes. This equipotential plane helps to prevent dangerous touch voltages from developing in the event of a ground fault. By requiring the bonding of metal studding, the code aims to enhance electrical safety in buildings with metal frame construction, protecting occupants from electrical shock hazards. In summary, the 2008 National Electrical Code introduced several important changes that impact electrical installations in various settings. The requirements for listed wet location receptacles, the expanded zone around wet and damp locations, the potential expansion of ground fault circuit interrupter protection, and the bonding of metal studding all contribute to enhanced electrical safety and improved protection against electrical hazards. These changes reflect a continuous effort to update and refine electrical codes to keep pace with evolving technologies and safety concerns. It is essential for electrical contractors, inspectors, and other professionals in the electrical industry to stay informed about these code changes and to ensure that their work complies with the latest requirements. Understanding and implementing these changes will help to create safer electrical systems and protect people from electrical hazards. The requirement for receptacles in wet locations to be listed as suitable for wet locations is a critical safety measure. Wet locations present a significant risk of electrical shock due to the presence of moisture, which can compromise the insulation of electrical equipment and increase the likelihood of current leakage. By requiring receptacles to be specifically designed and listed for wet locations, the code ensures that they can withstand the harsh conditions and maintain their electrical integrity. These receptacles are typically constructed with materials and features that provide enhanced protection against water intrusion, corrosion, and other factors that can degrade their performance and safety. The expansion of the zone described in 410.4. Point 4D is another important change that aims to improve electrical safety in bathrooms and other areas with bathtubs and showers. By clarifying that the zone applies generally, the code ensures that all electrical equipment and wiring installed within the zone are suitable for wet or damp locations. This includes receptacles, lighting fixtures, switches, and other electrical devices. The requirement for weatherproof covers on receptacles located within 3 feet of a shower or bathtub is an additional safety measure that helps to protect against water intrusion. Weatherproof covers are designed to prevent water from entering the receptacle, reducing the risk of electrical shock. The potential expansion of ground fault circuit interrupter protection to all branch circuits is a significant enhancement to electrical safety. Ground fault circuit interrupters are highly effective at detecting ground faults and quickly interrupting the circuit to prevent electrical shock. By expanding the scope of ground fault circuit interrupter protection to all branch circuits, the code would provide an additional layer of protection against electrical hazards in a wide range of applications. The requirement for bonding of metal studding is an important measure to ensure electrical safety in buildings with metal frame construction. Bonding metal studding helps to create an equipotential plane, reducing the risk of electrical shock by providing a low impedance path for fault currents to flow back to the source. This equipotential plane helps to prevent dangerous touch voltages from developing in the event of a ground fault. The 2008 National Electrical Code also includes other changes that are not specifically mentioned here, but it is important to consult the complete code for a comprehensive understanding of all the requirements. Some of the other changes may address issues such as surge protection, arc fault circuit interrupter protection, and energy efficiency. These changes reflect a continuous effort to improve electrical safety and performance in buildings and other structures. The 2008 National Electrical Code represents a significant step forward in electrical safety and performance. The changes discussed here, along with other changes in the code, aim to protect people from electrical hazards and to improve the reliability and efficiency of electrical systems. It is essential for electrical professionals to stay informed about these code changes and to implement them correctly in their work. The requirement for listed wet location receptacles ensures that electrical connections in damp environments are safe and reliable. The expansion of the zone around wet locations provides additional protection against water intrusion and electrical shock. The potential expansion of ground fault circuit interrupter protection offers greater protection against ground faults and electrical shock hazards. The bonding of metal studding helps to create a safer electrical environment in buildings with metal frame construction. All of these changes contribute to a safer and more reliable electrical system. Electrical codes are regularly updated to reflect the latest advances in technology and safety practices. It is important for electrical professionals to stay current with these codes to ensure that their work meets the highest standards of safety and performance. The 2008 National Electrical Code is a comprehensive document that addresses a wide range of electrical issues. It is essential to consult the complete code for a thorough understanding of all the requirements. The code is organized into articles, sections, and subsections, each of which addresses a specific topic. The code also includes tables, figures, and examples to help clarify the requirements. The 2008 National Electrical Code is a valuable resource for electrical professionals and anyone involved in electrical work. By understanding and following the code, we can help to create safer and more reliable electrical systems. The 2008 National Electrical Code also addresses issues such as wiring methods, overcurrent protection, grounding, and bonding. These are all important aspects of electrical safety and performance. Wiring methods refer to the types of cables and conductors that are used to carry electrical current. The code specifies the types of wiring methods that are permitted in different locations and applications. Overcurrent protection refers to the use of fuses and circuit breakers to protect electrical circuits from excessive current. The code specifies the size and type of overcurrent protection that is required for different circuits. Grounding refers to the connection of electrical equipment to the earth. Grounding helps to prevent electrical shock by providing a low impedance path for fault currents to flow back to the source. Bonding refers to the connection of different metal parts of an electrical system together. Bonding helps to create an equipotential plane, reducing the risk of electrical shock. The 2008 National Electrical Code also includes requirements for special equipment, such as transformers, generators, and motors. These requirements are designed to ensure the safe and reliable operation of this equipment. The code also addresses issues such as emergency power systems, fire alarm systems, and communication systems. These systems are critical for safety and security in buildings and other structures. The 2008 National Electrical Code is a complex and comprehensive document. It is essential for electrical professionals to have a thorough understanding of the code to ensure that their work meets the highest standards of safety and performance. Continuing education and training are essential for electrical professionals to stay current with the latest code changes and best practices. The electrical industry is constantly evolving, and it is important to keep up with the latest development. The 2008 National Electrical Code is just one of many resources available to electrical professionals. Other resources include industry publications, trade shows, and online forums. By taking advantage of these resources, electrical professionals can stay informed and improve their skills. The goal of the 2008 National Electrical Code is to protect people and property from electrical hazards. By following the code, we can help to create safer and more reliable electrical systems for everyone.